Welcome to today's lesson. In this first tutorial, we will perform operations with functions. And we are back in chapter 6, 6.3. And let's say that we have two functions. I want to show you the four operations that we can do. Let's say we have f of x and g of x. We can make a new function called h of x by performing any one of these operations. We have addition, so therefore h of x would be equal to, let's say we take f of x and add g of x. Pretty simple because we must see a plus sign. If we were to subtract, then our new function h of x would be f of x minus g of x. Again, pretty simple. We already know what the minus sign looks like, so that would be subtraction. For multiplication, if we wanted to multiply two functions together, then our new function would be f of x times g of x, and we'd be using our multiplication dot. And finally, for division, let's say that h of x is f of x divided by g of x. Now we do have to watch out for division because once we include a denominator, we know that denominators can never be equal to 0. So if we're going to do this division, g of x, that function, cannot be equal to 0 because we can never divide by 0. So these are the four operations we can do with our functions. We just have to make sure that we're using the correct functions and of course using the correct operation. So let's look at our first few examples. I've given you a bank of functions: a of x, b of x, c of x, d of x, e of x, f of x, and g of x. So we have these 7 functions and we're going to perform certain operations. Our first example, a of x plus b of x. Okay, so that means that we're going to be adding two functions together. Let's take the a of x function, which is 8x to the 3 halves, and we're going to put a big plus sign in between that and b of x. The b of x function is 12x to the 3 halves. So we have these two functions and we want to try to add them together. Well, these obviously have the same variables. They both have x's, and those variables have the same exponents. So therefore, these are like terms, and I can simply combine their coefficients. 8 plus 12, of course, is 20, and then we have x to the 3 halves. So like terms, remember, have to have the same variables, but those variables have to be to the same exponents. We could not say take 8x and add that to 12x squared. These have the same variables, but they are not to the same exponents, so they are not like terms, and we would not be able to add them together. We'd just have to write them side by side. If we were trying to subtract them, that would be fine. We're taking the same two functions, 8x to the 3 halves, and we're subtracting 12x to the 3 halves. Same thing with subtraction. You can only subtract like terms. Since these are like terms, we already talked about that, we simply subtract their coefficients. 8 minus 12 is negative 4x to the 3 halves. And we're finished. Alrighty. Let's look at two different functions, c of x and d of x. And what are we going to do with these two functions? Multiply. That's our multiplication dot. So we know we're going to multiply these two functions together. I have 6x squared y cubed, 6x squared y cubed, and I'm going to multiply that to 9x squared y to the 6th. 9x squared y to the 6th. For addition and subtraction, you must have like terms. For multiplication, you just get to multiply your stuff. You've got a 6, you've got a 9, you're multiplying them together, you get 54. X squared times x squared is x to the 4th because we add the exponents. Y cubed times y to the 6th, it doesn't matter that they don't have the same exponents because we're multiplying. We can multiply whatever we want. 3 y's multiplied together, and then another 6 would make 9 total. In other words, 3 plus 6. So we multiplied those two functions. Let's see what else we have. Now we're doing a division. I know that because I see my fraction, my division. C of x, let's see what we have for c of x. Oh, it's the same one. 6x squared y cubed. And we're going to divide that by d of x. 9x squared y to the 6th. 9x squared y to the 6th. Let's remind ourselves how to divide with our exponents, and I'm just going to make it equal to, let's do the numbers. 6 divided by 9, that reduces to 2/3, so I'll just put 2/3. And now let's deal with my variables. I have 2 factors of x in the numerator, and you know what? I have 2 factors of x in the denominator. Well, so those basically cancel away, and we don't have any x's left in our final answer. I have 3 factors of y in the numerator and 6 in the denominator. So all 3 of these will go away and take 3 of these from the denominator away. But there still will be 3 factors of y in the denominator, and that's our final answer. We'll come back and talk about domain with this fraction in a little bit. Okay, let's look at number 5. E of x, and we're subtracting f of x. Okay, 2 different functions. We've got x plus 1, that's a binomial. Binomials I like to put in parentheses. And we're subtracting f of x, that's a trinomial. Especially when I'm subtracting, I better watch out. I'm going to put this entire trinomial in parentheses, x squared minus 2x minus 3. If you forget to put the whole thing in parentheses, you're going to forget that you're subtracting all 3 parts of your trinomial. So watch out for this. This is actually a distribution. We're subtracting all 3 of these parts. We really didn't actually need these parentheses, but they didn't hurt. 1 times that is just that, so x plus 1. And then we're subtracting x squared. We're subtracting negative 2x, which makes positive 2x, and we're subtracting negative 3, which makes positive 3. Now we have these 5 terms, and I want to see if I have any like terms to combine. I go to the one with the highest degree first, and actually that's the only term with the squared, so I'm going to write that one first, negative x squared. And then I'm going to look at the x and the 2x and make 3x. And then I'll look at the 1 and the 3 and make 4. Put it in nice standard form. And finally, e of x times f of x, same 2 functions. This time, since I'm multiplying, I definitely want to make sure that they are in parentheses. And the second one is x squared minus 2x minus 3. This is going to be similar to a FOIL problem. We have to do a triple distribution. We're going to multiply x here and here and here. So x times x squared is x cubed. X times negative 2x is negative 2x squared. And x times negative 3 is negative 3x. We're also going to have to multiply the 1 here and here and here. 1 times x squared is x squared, and I'm going to put it right underneath its like terms. 1 times negative 2x, of course, is negative 2x, and 1 times negative 3, of course, is negative 3. I'm going to draw my line, and we're going to add all of our like terms together. Our x cubed, of course, nothing combines with that. We had negative 2x squared, and we added a positive one, so we're only at negative 1x squared now. Negative 3x and negative 2x make negative 5x, and of course the negative 3. So this is sort of a review of doing a bunch of things with functions. We can add, subtract, multiply, and divide. Let's look at the same 7 functions, and let's talk a little bit more about function notation. E of 2. This time we're not using our variables x. We're going to replace our variables x with numbers. E of 2 means that we're going to talk about this e of x function, but instead of having an x in it, we're going to have a 2 in it. So the 2 is going to go right there. So e of 2 becomes 2 plus 1, or rather 3. G of negative 5, that simply means we're going to take the g function. Here it is. The g function says take your input, your x, and square it, and then subtract 4. So g of 5 is going to take our input, g of negative 5 is going to take our input of negative 5, we're going to square it, and then we're going to subtract 4. Something squared minus 4. That's exactly what g of x says, something squared minus 4. So this is 25 minus 4, which is 21. So I have found e of 2, that's the number 3, and I have found g of negative 5, that's the number 21. What am I going to do with those two numbers? I'm going to add them together. I'm going to take the 3 and I'm going to take the 21, I'm going to add them together and make 24, and that's my final answer. So it's pretty simple. All you do is know which function you're talking about and put the 2 or the negative 5 or whatever number into that function in place of your input. What if I wanted f of a? Okay, so instead of plugging in a number, now we're plugging in just a different letter. If f of x has all this stuff with x's in it, then f of a would have all this stuff but with a's. So the a is going to go and take place of that x, and it's going to go and take place of that x. So f of a is simply a squared. Instead of minus 2x, it's minus 2a. And instead of minus 3, well, there's nothing to change that. It's still minus 3. The only thing that changes is we've changed the letter from x to a. That's what f of a would be. So if you can understand what f of a is, it should be pretty simple to understand what g of x plus 2. This time we're taking the g function, and instead of an x, it's going to have x plus 2. This entire binomial is going to go right in here for that little spot. So it's still something squared minus 4, just like over here, something squared minus 4. This time the something that's being squared is x plus 2. So it's x plus 2 squared minus 4. We took out the x and we put in x plus 2. The squared is still there, the minus sign and the 4 are all still there. So now we're squaring a binomial, which of course means right side by side. So we can FOIL. Don't forget the minus 4. X times x is x squared. X times 2 is 2x. 2 times x is another 2x. 2 times 2 is 4. And don't forget the minus 4. And now let's get our like terms together. X squared. 2x and 2x make 4x. And these terms actually go away. So that was a quick review of function operations. Be careful that you're using the correct functions, and then make sure you're plugging in the correct either letters or numbers and doing your math correctly. And we'll practice this when we see you in class. Thanks for watching this tutorial. I'll see you in the next tutorial. Bye-bye.